자, 미드텀 이그젠 퀘션 5가 as I told you, 여러분 말한 대로 this is a most difficult question in 미드텀 이그젠. 내가 시험 문제 내고 나서 보니까 좀 어려웠던 것 같은데. When I grade midterm exam, I found that this is not easy. A pair of coin is tossed 300 times. Pair of pair coin이다. Pair coin. Toss 300 times toss 됐네. Let x 100. Number of head in the first 100 toss. 여기에 number of head in first 100 toss의 number of head고 x 300는 number of head in 300 in all 300 toss 이렇게 돼 있네. Find the correlation x100 and x300. 요게 퀘션이네. Find correlation. As you know, correlation is okay. Most of them you know that correlation is a formula of a correlation is given as a covariance x 100 and x 300 divided by square root variance x 100 times variance x 300. 요거 x100이나 and x300 because this is a count of success, count of head in toss and pair coin이니까 binomial distribution을 가진다. 요거는 binomial distribution. 그래서 what is the variance x100? variance x variance comparison np 1 minus p지 np times 1 minus p the variance formula. variance formula 보면 I already midterm exam에서 그 variance and expectation of probability distribution에서 내가 reference 리스트도 줬잖아. np n은 100 0.5 하면 25. variance x 300 is np 1 minus p, p is 0.5, n is here is 300 times 0.5. So many students know that the formula of correlation is covariance x100 and x300 divided by square root of variance x100 and variance x300. So many students know that variance x100, variance x300 is given as 25 and 75. 이건 알아. The difficult part is calculating this covariance x100 and x300. 여기 actually frankly 솔직하게 여기 어려워. 요거 is difficult to find this covariance. then how can we know that covariance of two random variable? Covariance. So I will show you two solutions. So mathematics, as I told you, many ways to solve the question. Many ways to solve the problem. So let's see covariance. X100 means if X100 is write the variable X100 another form. Because this is the number of head in first 100 toss 때문에 this is H1 plus H2 plus, and this is 베르누리 트라이얼 또는 베르누리 랜덤 베리블이라고 볼 수 있지. 이렇게 베르누리 랜덤 베리블. 그러니까 요거는 시그마 I is from 1 to 100 HI 이렇게 표현해 보죠. Let's say it like this. And X300, let's write I is 1 to 300 H. 요거 J, 요거 different index J 이렇게 써보자. J. Covariance. So covariance X100 and X300 is covariance I는 1 to 100 HI times I, because we have a different index I and J 이기 때문에 2 sigma first J is 1 to 300, we can write like this HI and HI times HJ 이렇게 쓸 수 있지? 이렇게 쓸 수 있어. 근데 이거는 this is the same as, because this is a sigma is always, sigma means plus addition 이제 더하기 이기 때문에 this can be rewritten. 다시 이렇게 쓸 수 있어. 이렇게 covariance HI and HJ, and instead of X100, X300, this is a binomial distribution random variable. Instead, calculating covariance X100, X300, 이거 대신에 we can calculate covariance between HI, HJ. Here, HI, HJ is 베르누이 랜덤 베리블 이렇게 쓸 수 있어. 베르누이 랜덤 베리블. HI and HJ. This is dependent or independent covariance. 요거 HI. Is this two random variable HI, HJ? 요거 베르누이 랜덤 베리블인데 요거 independent because tossing a coin은 always independent지. Always independent. 그래서 we can write this는, that means covariance HI, HJ if I is not equal to J 하면 covariance는 요거는 제로가 되죠. 제로. 제로가 돼, covariance. Because independent니까. Always covariance HI and HI. 요거만 넣어. If I is not equal to J, if I is same as J, 요거는 not zero. 이렇게 돼. 그럼 요거 what is this? What is this? This is the summation of all two summation I and J. two-dimensional summation이야. Summation of covariance HI and HJ. Here, but this equation becomes very simple. Why? HI, HJ are Bernoulli random variable, and each Bernoulli random variable. Bernoulli, H is just a single tossing a coin. 한 번 던지는 거, just one toss. 그래서 HI, HJ, independent. Covariance to random variable, covariance if two random variable is independent, covariance is zero. covariance zero. If I하고 J하고 같으면, if I and J is same, what? This becomes what? This is 뭐가 돼? variance가 되지, variance. variance HI가 되지. 맞잖아. covariance X, Y, covariance X and X. What is covariance X and X? This variance X지. 이렇게 되지. 네. 요거 요렇게 X, X, two random, the same random variable covariance는 variance X지. 그래서 요거만 외고 variance HR만 남아. 그럼 요거는 뭐가 되냐면 I만 남고 variance I 이거만 남고 variance H. 이렇게 남고 because I는 100까지 가고 J is from 1 to 300인데 the scope of I is from 1 to 100. Scope range of J is 1 to 300. I and J should be same 돼야 되니까 네? intersection area, intersection scope는 from 1 to 100이지. 이래서 100이지. 그러면 요거는 variance HI하고 요거는 100까지 이렇게만 있으면 되지. 맞나? So covariance H100 and X300 becomes now I is 1 to 100. variance HI 이렇게 되네. variance is also this variance computations can be moved to out of this sigma. So variance HI I is 1 to 100 이렇게 된 거야. 근데 이거 뭐지? 이거 XI variance X 100 이렇게. 25, 25. 그래서 correlation X100, 100, X300. 이거는 아까 어떻게 됐지? 약간 square root 25, 75, and 여기가 25 이렇게 되네. This is the solution. 이렇게 돼. 조금 어려웠나? To solve this equation with this solution this way, you have to know the covariance is given as summation of Bernoulli random variable. H300 is a summation of another Bernoulli random variable. And the covariance가 요게 the covariance of total whole summation이 covariance of summation of each covariance between HI, HJ. 요걸 알아야 된다. You have to know this can be same as this. This equation is the same as this equation. You have to know this. So maybe difficult for you to solve this way. Another way is okay. Solution 2 해보자. Solution 2, another solution. Using just the regular formula of covariance. Covariance, let's solve, because the solution of covariance with this form is maybe difficult for you. Then you can solve another way using the covariance formula. What is the covariance? What is the definition of covariance? Definition으로 풀어보자. Let's solve definition of covariance. 여러분 definition 이렇게 가는 거 아니야? 이거 covariance, what is the definition of covariance? Expectation. X100 is one variable, X300 is another variable, X100 minus X100 is mean, and X300 minus X300 of mean, expectation. 이렇게 풀지. 이렇게 풀면 되잖아. 그럼 어떻게 해요? 요거 멀티플리케이션 하면 요거 해볼까? 요거는 X100 times X300 minus X300 X100 mean minus X. Actually this is a expectation of X100 times X300 minus X100 mean X300 mean 이렇게 되지. What is the mean of X100? What is the mean of X300? Mean is NP. N times probability P. 그래서 요거는 50. 요거 mean of X300 150. Because NP잖아 그냥. Mean is NP. If X is a binomial random variable, mean expectation is N times probability. Probability here is tossing coin 0.5. So it is easy. So how can we calculate expectation X100 and X300 times X300 times the X100 times X300. Okay, this can be we have to also use this formula. This is expectation sigma I is 1 to 100 hi sigma hj j is 1 to 300. This is the same way I and j 2 sigma. So expectation can be moved to outside of this sigma to inside of this sigma. 이렇게 expectation h I h j 이렇게 할 수 있어. So here we have to think also where I is the same as j, I is j, and I is not equal to j. 이렇게 두 개 생각해야 된다. hi, hj, is this two random variable? Is this independent? 이거 independent지? two random independent이기 때문에 expectation, two random variable expectation. If two random variable independent expectation becomes expectation hi, expectation hj 이렇게 되지. 이렇게. If I is not equal to j, if I is same with j, I 이렇게 되고 I 이렇게 되고 expectation if I is equal to j 이렇게 되면 hi의 스퀘어 이렇게 되지. 요거는 100 가지고. 그럼 이렇게 되면 expectation I and j 인덱스가 separate 분리되잖아. separation 됐잖아. 그럼 separation 됐으니까 이렇게 expectation 그 다음에 another expectation 이게 뭐지? 이거는 x의 100의 민하고 이거는 x의 300의 민하고 똑같아. same. only remaining part is 요거만 남아. 요렇게. 요게 뭐냐면 요게 25 되고 요건 또 x 100 mean of x 100 times x 300 mean 마이너스 요거니까 요거 150 is minus 150 times 150 so you can delete this all so remaining only you have 25 is left 남는다 left 그래서 25 그래서 이런 this way solution to this way you can also calculate covariance 25 이렇게 구할 수 있어. 좀 어려웠죠? It's difficult. 좀 어려웠지? So question 5, frankly, no one solved the question. 아무도 못 풀었어. 아무도. No one perfectly solved the question 5. Many students derive correlation is covariance x and y divided by the variance x, variance y. 이렇게. This is okay. Many students derive this formula. And the variance x 125, variance x 375. So many students solve the denominator variance y, but covariance 요게 no one solved perfectly this covariance. So when I grade exam, this we have a midterm exam. When I grade midterm exam midterm 할 때 교수님은 always 항상 I think I told you when you have at the date of a midterm exam, when you solve the midterm exam, I told you that write anything you think the solution, how you solve the questions. 그 solve question 문제를 풀으라 했잖아. So for me, actually, when I grade exam, I fully look at how students solve this problem, this question. The way of solution을 본다. The mathematics는 the answer, just the writing answer is not important. The more important thing is how you solve the question. What is your approach? 접근법. How you approach, how you solve any question with some approach. 이런 거 보였어요. 그래서 그레이딩은 exam grading every time 교수님이 직접 매기고 교수님이 그래서 any writing, any solution related to the question, I grade some point. 그치? That's why most question has 5 grade, 5 point. So in between from 1 to 5, I look at your solution, then I give a point. So question 5, no one has a full 5 points, but many students have just some part of a point. Okay, let's go to textbook chapter 5. We are now studying normal distribution. Normal distribution and standard normal distribution. Suppose X is a normal distribution. X is a random variable with a normal distribution. Means if X is a we can write the equation like X tilde n mu mean or expectation and the sigma square. This is a variance. Sigma is the standard deviation. Sometimes let's say G. Sometimes random variable with a standard normal distribution instead of X, letter X, alphabet X, we use sometimes G, alphabet G, stand for standard normal distribution. That means G is in equation, in symbol, G is a tilde normal distribution with a standard normal distribution has a mean 0 and variance and standard deviation is 1. 이렇게. standard normal distribution은 그냥 이렇게 always the single shape. The mean is 0 and standard deviation is 1. Okay. Normal distribution은 general normal distribution, ordinary normal distribution has some different types of this curve를 가지고 we can 이게 PDF probability density function이 되지. some sigma를 가지고 이거는 probability distribution function of standard normal distribution we write in equation pi x 이렇게 여기 g니까 여기 g니까 이거 g로 써야겠네. g 이렇게 instead of f PDF we write pi for probability distribution function of standard normal distribution이다. 그 다음에 요거는 뭐지? CDF는 캐피탈 레터 파이, 대문자 파이 이렇게 쓰자. So probability is 1 when G is 0. 좀 해야겠네. 이게 CDF가 되겠지. 요건 PDF가 되고. Let's talk Last week에서 요거 last week 클래스에서 there is the value of g. This is 거기다 파이다 파이. PDF of standard normal distribution. There is a value g called g alpha 이렇게. Remember this value g alpha. 요 g alpha를 어디를 g alpha로 불리냐면 g alpha. 요게 요 area of this area is alpha예요. alpha. 요게 1 마이너스 알파고. probability g is greater or equal to g alpha is alpha 이렇게 되죠. probability g is less or equal to g alpha is 1 minus alpha 이렇게 된다. We can call this value is critical point 라고 부른다. Let's call this value is critical point. There is another critical point. Okay. Also remember this critical point G. Here this 요거는 G 알파고 here 요거는 G half of alpha. 반이단 말이야. 알파의 반. 알파 divided by 2. half alpha. 여기 alpha means this area greater than G alpha. This area is alpha니까 half alpha means 요 area는 what is this area? The probability of this area is alpha divided by 2. half of alpha다 이 말이지. half of alpha. 그럼 여기에 because standard normal distribution은 always symmetric니까 there is another area. probability of this area is half alpha이지. 2분의 알파. So that remaining area is 1 minus alpha. probability of remaining area is 1 minus alpha 이렇게 됐다. 근데 then what is the value of this? This is minus g 이렇게 되겠지. half alpha 되겠지. 여기 제로. This is also critical point. This is also critical point. Let's see example later. example 나중에 보고. Remember the meaning of definition of this critical point or standard normal distribution에서 이걸 알도록 반드시. Then how can we convert or transform x to g? How can we transform x? Here x는 normal distribution mu의 sigma square고 g is standard normal distribution 0, 1 이렇게 되나? x then the solution is, the answer is G is X minus mu divided by sigma. 이렇게 하면 된다. So let's memorize this transformation. This is important. Why we have a transformation of x to g 이렇게 하느냐? Probability we have let's calculate the probability random variable x probability between a and b. That means 요거 meaning은 because x is a general 일반적인 ordinary 스탠다드 노멀 디스트리뷰션이기 때문에 ordinary 노멀 디스트리뷰션이기 때문에 디스트리뷰션이 뭐 이런 쉐입을 가질 수 있지. 그래서 요거는 x PDF of x 여기 되겠고 A and B. Let's calculate the area of this between A and B. Instead of calculating area between A and B in the random variable x, we can calculate using standard normal distribution pi. We can calculate where? Let's convert probability A. What is x? X is G sigma plus nu G sigma times G plus nu and if you solve this equation with respect to 요거 G로 풀면 this becomes the probability A minus mu divided by sigma G is from sigma G A minus A다 요거 A minus mu divided by sigma to B minus mu divided by sigma 이렇게. 그래서 여기 AB between AB this area is the same as somewhere here from A minus mu divided by sigma to B minus mu divided by sigma. 이게 same. 네. Probability is same. Actually, area보다는 probability is same. So calculating random when there is a normal distribution random variable x, if you want to calculate probability between A and B, this is the same as probability. Instead of x, use standard normal distribution function pi to calculate A minus B, A minus mu divided by sigma to B minus mu divided by sigma 이렇게 계산을 해주면 되겠다. 이거 using CDF of standard normal distribution capital letter pi 이거 어떻게 되지? pi 이거 capital pi. This is CDF of standard normal distribution. B minus mu divided by sigma minus pi A minus mu divided by sigma 이렇게. 요거는 뭐였지? 요거는 F CDF of X F B minus F A. Very simple example. Very simple example. Let's say x. For example, x is a normal distribution with mean is 3, variance is 4. That means sigma is 2. 2란 말이다. Let's calculate the probability x is less than 0. 6. Is the same as probability G is this is also minus negative minus infinity. 이거는 6 minus 3 divided by 2 이렇게 하면 되지. probability 이게 뭐지? 그 1.5네. pi, this is a CDF pi 1.5. What is the CDF 1.5? pi 1.5 가볼까? Let's look at the table of CDF. 1.5. If you look at the table of CDF of standard normal distribution, and the second page에 1.5가 있네. 1.5, 0.9332. 0.9332. 여기 테이블 보면 이렇게 vertical, horizontal 있는데, 예를 들어서 0, 0. 여기 G 밸류가 0.1 쭉 가서 1.5 보면 여기에 vertical axis에는 the value of g가 이렇게 있어. 0.1, 0.2 up to first decimal point 소수점 첫째 줄까지 up to first decimal point가 있고, horizontal axis에 보면 여기 뭐라고 적혀있지? 0.00 돼 있고, 여기 0.01, 0.02 해서 0.09 이렇게 있지. This means up to second decimal point. 소수점 두 줄짜리까지. 1.5는 1.5에 보면 이렇게 1.5 보면 0.9332 이렇게 돼 있지. 그래서 solution of pi 1.5는 여기 되고 0.33가 되고, if you want the pi 1.52 1.5이 구하려면 you can find 1.52는 1.5 and decimal point second decimal point 2. If you look at here, what is the value? This is 0.357인가? 0.9357 이렇게 돼 있지? You can use this table to find the value of CDF. 그럼 0.03 up to decimal point, second decimal point, if pi 1.53는 얼마지? 9370 0 여기는 0 포인트 이렇게 되네. 9370 이렇게 되네. 요거 요렇게고 요거 요거고. What is pi 1.525 이렇게 되면 there is no in the table there is no decimal third decimal point 그러니까 없잖아. 그러면 in between this value you calculate 뭐 exactly if you want to exactly calculate you can use these two value to find this. But here this is if this is 1.525면 exactly middle of 1.2, 1.52하고 1.53잖아. 그럼 exactly middle이니까 0.93 middle이 어디지? 13이니까 about let's add about 6 그러면 6, 3 그치? 한 이 정도? or 0.9364 뭐 이 정도가 오케이. 맞지? 이렇게 하면 되겠지. So this table, you have two tables. First page, two pages. First page is minus from minus infinity to 0.0, and second page is from 0.0 to plus infinity. But there is no plus infinity. See, look, what is the maximum value of in this table? Maximum value G is 3.4. 되겠지? What is if G is less than minus 3.4 or greater than 3.4? What happens if the G is, for example, 5? 이렇게 되면 어떻게 되지? 5. Almost, if minus 5, almost 0. 라는 이 말이지. So, not necessary to show the less than minus 3.4 or greater than 3.4 because it's 2, if G is greater than 3.5 then it's almost close to 1 1에 가깝기 때문에 그래서 굳이 필요 없지. So if X is a normal distribution with expectation, mean mu, and variance sigma square, then probability X is between mu minus C, constant C sigma. Here C is a constant. From mu minus C sigma to mu plus C sigma is, you can calculate this probability instead of X, you can use G to minus C to C 이렇게 계산할 수가 있네. 그래서 if C is 1, that means any PDF X, this is random variable X, this is mu, center is mu, 1 sigma, plus minus 1 sigma, minus sigma. This area, 요 area, This is the same as probability G, too sharp. Minus 1 to 1, this area. If you check the CDF table 보면 this area covers total, the probability is 0.68다. 이렇게 됩니다. (0.68) 이렇게 돼. If C is 2, mu 2 sigma. 2 sigma means 2 times x is probability. X is mu minus 2 times sigma from mu minus 2 sigma to mu plus 2 sigma. 요거는 probability that G is minus 2s 2 이렇게 된다. 이건 얼마냐면 0.95라고 돼 있네. That means from mean of random variable, probability from mean minus 2 sigma to mean plus 2 sigma is covers 95% of this whole area를 차지한다 이 말이야. 요게 전체의 95%라고 해야 되고 0.95 probability라고 해야 되고. 이렇게. If C is 3, that means probability X between mu minus 3 sigma to mu plus 3 sigma is covers almost all area of this X. This is a zero probability is 997. In percentage 99.7% 이렇게 돼. simple example 한번 볼까? Example of normal distribution. Example 18. Tomato plant height. Tomato plant height is mean is 29.4. Unit is centimeter. 토마토 플랜트다. 토마토 나무. And the standard deviation is 2.1. Sigma is 2.1 centimeter. In mathematics, you have to care. 유닛 반드시 조심해야 된다. 단위는 반드시 정확하게 짚고 넘어갈 것. What is height? range 범위가 뭐냐? which covers 99.7%. (99%를) 커버하는 토마토 플랜트 하이트 레인지는 뭐지? What is the height range? 토마토 플랜트 하이트다 지금. not 키. 토마토 플랜트 키. (99.7%라는 말은 99.7% means random variable x is range is mu minus 3 sigma to mu plus 3 sigma지. 그래서 mu가 있고 여기가 mu plus 3 sigma, mu minus 3 sigma. So what is here? Mu minus 3 sigma is 29.9 times 3 times 2.1. 요거는 29.9.4 플러스 3 times 2.1 이렇게 되겠지. 곱하기로 할까? 3 곱하기 2.1. 요거는 3 곱하기 2.1. 요 between 여기서 요 레인지 안에 99 tomato plant will be the height of a tomato plant will be between this area, this range. 이 말이 되겠지. Another question then. What is the height range? 토마토 플랜트 height range 얼마죠? What is the height range? Which 90% 해볼까? 90%. 90% of tomato plant maybe in probabilistic will be between here and here. 90%. What range or what interval of a tomato plant height will be here, between here and we don't know here, we don't know the value of here, but anyway, the question say that 90% of a tomato plant, this is a x다, PDF of x, this is x. (90% means probability는 0.9이다. probability. 그러면 remaining area, this area는 and this area. What is the probability of this area? 0.05. 0 point in probability, 0.05 tomato plant, the height of a tomato plant will be, the height is greater than this value. In probability, 0.05 tomato plant height will be less than this value. Let's say this is A and B. So tomato plant height, if tomato plant height has a normal distribution with a mu and standard deviation (90% of height), the interval will be maybe, because we can say maybe because 이거 probabilistic이니까 maybe between A and B. Then what is A? What is B? Because this is symmetric 때문에 symmetric probability는 symmetric이기 때문에 A와 B는 if this is A, this is A면 요거는 마이너스 A 되겠지. 요거 마이너스 A 되겠지. Because symmetric. Then what is A? What is A? To solve this question, you have to know the critical point. Beginning of this class, we write this. Something is 이렇게 Z alpha half of alpha divided by 2. Then what is this value? Half alpha means this half alpha means this probability of this area. This probability of this area is 0.05G. This means G 0.05. 요거는 마이너스 G 0.05가 되겠지. 그래서 instead of solving the question using random variable x, you can convert this, you can transform this to standard normal distribution with the probability this is 0.05, this area is 0.05. Here is the critical point is minus G 0.05. This is plus G 0. 이렇게 풀면 된다. 요거 G 요렇게로 이렇게. 요걸 A 이렇게 컨버트했어. 다른 말로 another word, 다른 말로 x, this is a random variable xg. 요건 random variable g, standard normal distribution이니까 probability x for this question we have probability x between range between 요 문제를 this probability를 we can calculate instead of x. We can use probability minus G 0.05 G 0.05 이게 얼마지? 이렇게. 그럼 요걸 구하면 된다 이 말이야. What is this? Actually, if you look at table, 이거는 G 알파만 나와 있네. 알파 여기 있지. If you look at the table of cumulative distribution function, page 1. If you look at the page 1, in the left side, you have a very, very small table. 여기 very small table이 있는데 여기 알파 있고 여기 G에 알파 있는데 알파가 0.1 있고 0.05 있네. 0.05. This means G 0.05 is 얼마로 되냐? 1.645 이렇게 돼 있네. 이렇게 돼 있네. You can also find the value of G, critical point G, 0.0 alpha using what kind of formula? 요거 어떻게 되지? 요거는 파이, 캐피탈 파이, G, 0.05 마이너스 이렇게. Actually, you can find also using this CDF table, you can find the value of G 0.0 alpha, which gives you 어떻게 되는 거? 이거 플러스 G 0.05 마이너스 파이 마이너스 G 0.5가 이렇게 0.9 되는 위치를 테이블로 찾으면 돼. You can find in table also. But usually this critical point alpha 0.1, 0.05 여긴 또 뭐가 있노? 0.025가 있고 0.001도 있고 0.005도 이렇게 있네. This critical point is given usually in table. For example, okay, that's the example today class. Example 37에 보면 concrete block weight 어떤 블락의 웨이트인데 블락 웨이트의 mean은 11 kg. Standard deviation is 0.3 kg. 이렇게 돼 있네. So what is the range of a concrete block? Which 99% of concrete weight maybe in interval or range 어디까지 있겠나? (99%) 99%란 말은 99%란 말은 여기 x 랜덤 베리블 x에 대해서 뮤 마이너스 c 시그마 뮤 플러스 c 시그마 이게 뮤가 있고 이 this area covers 얼마나 되냐면 probability 0.99 99%. 그럼 what is the remaining 요 에리아는 뭐지? This area. What is the probability of this area? This area 0.005. 맞나? 이렇게. 그러면 크리티컬 포인트는 스탠다드 노멀 디스트리뷰션에서는 GS는 이 크리티컬 포인트 G 0.005 요거 얼마가냐면 is given as in table critical point G 0005 is 2.576 2.576 이렇게 되네. 그러면 여기 this value, critical point value, you can replace with C. 이렇게 집어넣으면 what is range A and B? This you can calculate this from, if you get the textbook, this becomes from 10.23 to 11.77. Okay. So using the critical point value, if you want to calculate the critical point value, you have to find this critical point value. You don't need to memorize, you don't need to memory, because I will give you, if an example, I will give you in exam, I will give you a table of this critical point also. Then once you find this value, you can replace this constant C using this critical point. Then this becomes, 요거 이렇게 되고 6 플러스 C 시그마가 이렇게 되겠지. 오케이, 그러면 any question?